So this video is on differentiating inverse functions as well as inverse trigonometric functions. So it says find the derivatives and inverses of the given functions below. Show clear and logical work in the space provided. And then I also gave a formula of inverse derivatives. So it's going to be like this. And then number 1 says y equals x to the third minus 5 at 3 and 22. So we're trying to find f inverse at 3 derivative, okay, which can be given by 1 over f prime of 22. Okay, so we'll find f prime, so y prime equals 3x squared, and then y prime 22 equals 3 times 22 to the power of 2. Right, so our answer is going to be 1 over 3 times 22 to the power of 2. Okay, moving on to the next one. It says g of x equals x plus 4 all over x, and then at 2 and 3. So again, we're going to say f inverse at 2, or g here. Okay, g inverse at 2, prime equals 2, 1 over g prime of 3. Okay, so that means that we have to take the derivative. So y prime at g prime x equals quotient rule. So 4, negative 4 all over x squared. G prime 3 is going to be negative 4 all over 9. Okay, so our answer is going to be 1 over negative 4 over 9, or 1 over 9 over 4. Okay, and then f of x equals 2 cube root of x minus 1 at 9, 2. So for this one as well, we're going to try f inverse at 9 prime is equal to 1 over f prime 2. Right? Okay, and then, so we're going to take the derivative of f of x, which is going to be to the power of 1/3. So f prime x is going to be 1/3 times x minus 1 to the power of negative 2 over 3. Okay, so f prime 2 is going to be 1/3 times 1 to the power of 2 over 3, or just 1/3, right? Okay, so our answer is going to be 1 over 1/3, or just 3. Okay, for additional explanation, the reason why we have this form, right? This form, f inverse of a derivative is going to be 1 over f prime b, is because so we put b in here because this b was actually supposed to be 1 over f prime of f inverse of a, right? And then inverse of a would give us b, right? F inverse of a would obviously give us b, right? So that means that we're just going to have 1 over f prime of b, right? That's the principle of inverses, which is why we have a simple formula. It's just 1 over f prime b. But then you might also be familiar with this form as well. But if you kind of simplify it, you get the equivalent form of 1 over f prime b. Okay, so for the next one, it says find the derivative of h of x equals sine to inverse of 5x to the power of 4. So sine actually has a given inverse formula that you can use, so we can use that one. H prime x is equal to, or before we start, I'm going to write out the formula. So sine inverse of x, or y equals y prime is equal to 1 over square root of 1 minus x squared, right? Okay, so h prime of x is going to be 1 minus 5x to the 4th, okay, squared, and then inside a square root, and then we're going to use chain rule, so 20x to the 3rd power multiplied, so it's going to be 20x to the 3rd all over square root of 1 minus 5x 4th to the power of 2. If you want to simplify, I can just write that as 25x to the power of 8. And then it says, find the derivative of y equals 6x to the 3rd times cosine inverse of 3x squared. So cosine inverse is derivative can be given by y prime equals negative 1 over square root of 1 minus x squared. So to find the derivative of the given function, we can use product rule. So y prime is going to be equal to 18x second cosine inverse of 3x squared, and then plus negative 1 over 1 minus 3x squared to the power of 2 is going to be 9x to the 4th power times derivative of 3x squared chain rule, right? That's going to be 6x times 6x to the 3rd power. Okay, so simplifying this a little bit further, we can say 18x squared cosine inverse 3x squared minus 36x to the 4th root 1 minus 9x to the 4th power. Okay, so this will be our answer. Okay, and then moving on. It says g of x equals tangent inverse x all over 5x squared minus 1. So obviously here we're going to be using tangent inverse derivative and also quotient rule. So g prime of x is going to be equal to tangent inverse x derivative, which is going to be 1 over 1 plus x squared times 5x squared minus 1 minus 10x, right? Yeah, 10x times tangent inverse x all over 5x squared minus 1 to the power of 2. And honestly, there's nothing much to simplify here except for the fact that we have a fraction over fraction. So we're just going to write this as 5x squared minus 1 all over 1 plus x squared minus 10x tangent inverse x all over 5x squared minus 1 to the power of 2. So here I'm just going to combine the denominator. So 5x squared minus 1 minus 10x tangent inverse of x times 1 plus x squared all over 1 plus x squared, but then we have this one on the bottom, right? So we're going to simplify this. So this will be our answer. Okay, so for number 7, the cosecant inverse derivative formula. So let's just try to take the derivative. So f prime is going to be equal to 1 over e to the x absolute value, and then square root of e to the x squared minus 1. Okay, so, and then we're going to take the derivative of e to the x, right? Because it's chain rule, and we get e to the x. So e to the x over inverse e to the x, and then e to the 2x minus 1. Okay, and then we have one e to the x and one absolute value e to the x, right? So e to the x, if you draw the graph, you're going to get a graph like this. Oh, oops. So e to the x is actually never going to be negative, right? It's always positive. So there really is no point in having e to the x an absolute value. So e to the x over e to the x, root e to the 2x minus 1. So cancel these out. So you get 1 over root e to the 2x minus 1. Okay, moving on to number 8. G of x equals x to the third times cotangent inverse x. So again, we're going to be needing the cotangent inverse derivative formula. Okay, and then we're going to be using product rule. So g prime of x is going to be equal to 3x squared cotangent inverse x plus cotangent inverse derivative negative 1 over 1 plus x to the second power times x to the third power. So 3x squared cotangent inverse x minus x to the third all over 1 plus x squared. Okay. Moving on to number 9, h of x equals secant inverse cosine x. So h prime x is going to be equal to 1 over cosine x, right? And then cosine squared x minus 1. And then we're going to do negative sine x, right? Chain rule. So negative sine x all over absolute value cosine x times cosine squared x minus 1. Okay, moving on to number 10. So it's now cosecant inverse of 1 over x. So we can say y prime is equal to negative 1 over absolute value of 1 over x times root 1 over x squared, right, minus 1. And then we're going to say negative, so x to negative 1 power, so negative x negative 2. Okay, so that means we get negative cancels out. So x squared times 1 over x times 1 plus x, 1 over x squared minus 1 all over 1, right? Okay, and then 1 over x is going to have a graph of this, right? Okay, and simplifying this a little bit further, we get 1 all over absolute value of x, and then square root of x squared minus 1 minus x squared all over x squared. And I think we're just gonna leave this like this. It's gonna be a little bit too complicated to like rewrite everything, so we're just gonna leave it like this. And yeah, that'll be it. And then going off to number 11, g of x equals to cotangent inverse of e to the cosine x. So we have to use chain rule here as well. So g prime of x is going to be equal to negative 1 over 1 plus e to the cosine x to the power of 2. And then you have to do negative sine x times e to the cosine x, because that's chain rule. Okay, and the negatives cancel, so we're going to have sine x times e to the cosine x all over 1 plus e to the cosine x to the power of 2. So for this problem, we have to take the derivative of y equals first. So y prime is going to be 10x times cosecant inverse 3x, and then plus minus 1 all over 3x absolute value, and then 9x squared minus 1, and then times 5x to the second power, and also times 3, right, for chain rule. So we have 10x cosecant 1 inverse 3x minus 5x all over 9x squared square root minus 1, right? So this is going to be our y prime. To find y prime at x equals to 2, we have to put this into our calculator. So we get around 1.659 as our dy dx value. So we're going to use point slope form again. So y minus y1 equals dy over dx times x minus x1. So y minus 3.349 equals to 1.659 times x minus 2. So this will be our answer.